Hi everyone, in this video I will be demonstrating my SN74LS181 arithmetic and logic unit module, which is the final stage before building the full CHUMP processor. The goal of this stage is to assemble, test, and understand the 64 observable functions the 181 can perform. This includes 16 logic operations and 16 arithmetic operations, each of which can be executed in either active high or active low mode. I will also show how these functions support the Chumpinese instructions I will run in the complete CHUMP. The SN74LS181 has several groups of pins that control how the ALU operates. The first set is the operand inputs, A0 to A3 and B0 to B3. They are active low inputs, meaning the ALU interprets a logical 1 when the line is low. I control each of these inputs through a 8-position dip switch bank so I can quickly set any 4-bit value for A and B. The next group is the function select inputs, S0 to S3. These 4 lines choose one of the 16 logic functions or one of the 16 arithmetic functions. In my build, they are connected to a CHUMP clock module, so I can cycle through all 16 operations either manually with a button, like so, statically with the dip switches, or automatically using the 555 driven potentiometer clock. After that, we have the mode and carry inputs, M and CN. These 2 pins determine whether the ALU is in logic mode, like it is right now, or in arithmetic mode, and whether the inputs are interpreted as active high or active low. Now, the outputs F0 to F3 represent the 4-bit result of the selected function. These outputs are also active low, so a low level on an LED indicates a logical 1. I connected a LED bar graph to the pins to visually represent the 4-bit results. Next, the A equals B pin is the comparator output. It is an open collector pin, meaning it behaves like a transistor whose output floats when it's inactive. When A is not equal to B, the transistor is off and the line is pulled high by an external resistor. When A equals B, the transistor switch on and pulls the line low, which turns on the LED. I will represent that right now. Next, I connected the C and M pins to an Arduino, running a simple program that displays if the ALU is using active low or active high, as well as representing if it is using logic or arithmetic operations. Now here are some logic functions you are probably familiar with. XOR. XOR will produce a high value when there is only one value. A0, B0 has none, A0, B1 has 1, shown by this LED, A1, B0 has 1, shown by this LED, A1, B1 has 2, so it does not show by the LED. Next is AND. AND is pulled high when both of the values are equal to 1. These first 3 values have at least 1 0 in them, so none of them are on. But the final one, A1, B1, both of them are 1, so we get a high value here on the LED. Finally, OR. OR is active when there is at least one value in the operation. A0, B0 is the only one without at least one 1, so it is off. But the 3 other values have at least one 1, so all 3 of them are on. Now, let's do some Chumpinese code. First, the address is at 0, and the machine code will be 1 here and 1 here. Assembly, this is read 2. One, and the rest of the zeros. In assembly, that is go to 0. Thank you very much for watching my video on the ALU, arithmetic, logic unit, and please stay tuned for the final videos coming soon.